with that, we're going over to our next presentation from Adam. Welcome, Adam.
It's super exciting to listen.
Yeah,
Till, it was an awesome talk, and thank you guys for inviting me.
you're warm welcome.
It's an honor, pleasure to talk here. So today I would like to talk about F sharp, just one of the languages that I think a lot of people nowadays who tend to check out functional programming and they end up liking functional programming. I think F sharp is one of those functional languages that actually get used quite a lot. I think there's a good tendency to pick up F sharp for commercial development, and it's just an awesome language. So my background is in functional programming going back to 2000. I've used a lot of OCaml, and around 2002, 2003, I started checking into F sharp. We were one of the first users of F sharp, commercial users at the end. And so that's my journey to functional programming. But today I would like to talk about applying F sharp to web programming, which is a very active topic nowadays. And hopefully I can show you guys some interesting bits that will cause some people to check this out. So I'm from a small company called IntelliFactory, and we basically specialize on development tools. So WebSharper is one of these open source tool sets that we have developed. We have almost 400 F sharp repos and roughly one of the largest F sharp code bases, I think, globally. So I'm pretty proud of that. So, okay, so today I want to basically, I thought about this a lot. I think it's best to kind of tip our toes into how you do things from a practical angle. So we start with a pragmatic approach. I'm going to try and create a couple of web shop applications, and we check on the code, and then I'll talk about some other things more in general, like sitelets. How do you bring in existing JavaScript code bases into your full stack F sharp web applications using WIG, which is the WebSharper.InterfaceGenerator. It's an embedded DSL into F sharp. And I'm going to give some further pointers so that if you are interested, you can check out other stuff. In particular, I think I'm going to even maybe show, if we have time, a WebSharper charting example, how you can basically copy and paste some code from the repo and get going with that snippet in your applications. So let's do a basic small app. And just as I transition into this, there's a website here you can see in the bottom, the Try WebSharper website. It basically allows you to very easily just type in some F sharp code and try it. Basically getting it transpiled to JavaScript with WebSharper and running the JavaScript. I think I actually have this up and running here. So there's hundreds and hundreds of snippets. You can just click on any of these. For example, here's this one. I have no idea whose snippet it is. It's some user submitted snippet. You can change the code, you can break it. It will give you hover comments and other code assistance, red squigglies and warnings and type checking, code completion, etc. And then when you're ready to compile a project, you just hit run. As you can see, it's about maybe a sub-second time that it takes to compile it and then show the result. If you're happy with it, you can save it in the database. You can embed it into your blog posts, share the link directly with your peers or on social media. So it's a pretty cool website to actually try WebSharper and try F sharp web programming without having to install anything on your machine. Here's a pool game. I think this is the largest example, maybe about 1,000 or 1,200, almost 1,350 lines. So this is all in F sharp, and then you basically have this snow review. That was a horrible shot. In fact, we should teach that how not to do pool. All right, I'm gonna switch back here. So let's try WebSharper. So the first steps would be to get started with anything related to WebSharper. It's advisable that you install the templates that come with WebSharper. These are project templates that will allow you to actually get going very easily. Most of the templates are tiny, maybe 1, 2, 3, 4 files in each of the templates, 20, 30, 40 lines of code. So we're talking about minimal amount of boilerplate that you need to get that you need in order to get started. So I installed my templates. It takes that single command on the top. You need, of course, the .NET CLI, the command line interface for .NET itself. And then once you have the templates, you can just start creating different projects. For example, I have installed WebSharper, and you can see all these different projects. So here in the second column, if I wanted a .NET proxy project for WebSharper, I would use WebSharper.PRX instead of WebSharper app. So I created a project already. It's my app 01. So this is what we're going to be working in. So let me just open that. So I booted up Visual Studio Code. As I said, it basically has very small amount of content. There is some boilerplate that addresses the ASP.NET Core, the underlying web architecture. So basically we set up an application builder, we configure it, we stick in WebSharper capabilities. So this is, remember, just boilerplate code. The only thing that actually might be of interest is this one call here, where we actually plug in into the serving pipeline this particular application that we have in the other source file, which of course, as you can see, is a very tiny, a single line application here. So basically it just says there's only one entry point to this application, which is the root of the web application. And when you go there or request that from outside, from a browser or some other means, then we return textual content, so basically a string, and it will just say hello world. And needless to say, if you tested that, you would get that. If you try anything else, it's not going to respond because it only knows how to respond to the web root. So if you wanted to enlarge this is what I call, or this is what we call a sitelet. As you can see in the signature, so these are auto-generated. So I can hover over this identifier. I can see that it's a value of type sitelet over endpoint, where endpoint is basically the type representing the incoming requests. So one of the fundamental things that WebSharper.Sitelets give you basically is the representation of these endpoints within the type system. And then you build an abstraction over those endpoints. And if you build, for example, a microservice or a server-side enabled application, like a client-server application, or a, well, it doesn't have to be server enabled. You can have also static websites. These are also represented by sitelet. But anyhow, so you basically, you wrap or you abstract on top of your endpoint type, and then you create a sitelet. So there are different means to create sitelets. I think if you can just do this, you can see that there's the text, which is very simple. Usually it's used just to sort of signal that some sitelet has started and is operational and ready to be expanded. And once you start going into the development, then you typically either decide that you want to have a single page application, which is for mobile web applications, or if you have a true single page application, or more often you have a multi-page application. So if there's an alias you can use instead of application multi-page, which I think even is a more telling name, which is sitelet.infer. And the change here is that we have some context, but we also have an endpoint, and we need to then basically map over that endpoint. And another way to write that would be just basically doing an immediate pattern matching on the last argument. So here we would say we have, for example, some incoming values, and then we should just basically at this point now return some text. So now, of course, this is going to complain about the general value restriction. So we need to, at this point, unfortunately, you can't have a sitelet over obj, because that doesn't mean anything, because the type system encodes everything as objects, and it's a broad type basically given if you can't identify. And for sitelets, we need to be able to identify the actual endpoint type. So we need to basically at this point, we can basically say something like this, or we can type this particular pattern match case that it's an I of an int value. So anyhow, I basically just gave this extra type annotation, and now my sitelet is ready to be served. Let's see. So we have to move this up a little bit. So I have this application running already, but I'm going to run it again. In the background, so this is calling the .NET CLI. In the background, this compiles my application, and then it starts a web server on the default port, which is 5000 and 5001 for HTTPS. And then if I switch over to my application, and then if I reboot it, is it running? Seems to be. Well, anyhow, you can basically fetch the value that you receive and do something with it. So this is not a very interesting example, because now we are talking about, I guess this would be a small microservice, which now, instead of at the root, is now listening and trying to receive an integer argument, which of course, if you encode the request as a URL, it's going to have something like the root of the web application / and then a number. So then we basically, I mean, because we always return hello world, it's kind of silly. So here we probably want to do something with that I that we receive and then respond. So a typical example would be, for example, let me switch, just go a bit ahead. So here we would have the very same setup. I have an I that I receive. Here I actually defined on the top that I have my own endpoint type, which is basically just all the set of integers. And if I receive any integer value as part of a request, then I will basically square it. I will create a string out of it, and I return that back as a context or content, textual content. Very typically, you should probably not just return text, but you should return JSON values or XML values, depending on what kind of enveloping you use around the values that you communicate. So here's a couple other things that you can use. So content.text we have seen. This creates a textual value, so basically a string. You can also return JSON by creating a type, or you don't have to create a type or declare a type. You can actually use anonymous records, which very nicely actually serialize into JSON. But here I have actually a type called person, and then I have a value of that type, which is basically the argument given to content.json. And then this function then takes this value and basically serializes it. So this is a general way of getting from an F# value of any type into JSON. And it's a fully extensible model that we use inside. So you can configure your own serializers and add different serializers for some weird types that you may introduce within your type space for your values. But ordinarily, it works basically for all the atomic types. It works for most of the composite types, discriminated unions, records, sequences, lists, arrays, etc. So you can serialize and deserialize those values automatically. You can also return a file. So for example, a natural step would be at this point to say that I have a small server-side entity, which when you request will return some HTML. So I could have my designer produce an index.html for me, and then I can just basically pipe it back as a content.file and then give the URL to the source. Now, obviously, if I did that, I would be returning the HTML from my designer verbatim, and that's typically not what we want. I mean, sometimes that's okay and sufficient, but most of the time you also want to change something within those index or design template files. And that's where actually the templating comes in. and I have a few slides, and I will be talking about templating later. So let me just go on with this. So before we get to actually using templating, we have to realize that we need to elevate and treat separately the different types of contents. So when I say content.file, here I have an optional argument where I can supply what kind of content type I am returning that file as. If I have content.text, it automatically knows that it's going to be a string. If I have content.json, it will actually use the right content type with that response. So now if we have content.page, this will start to allow me to actually return HTML in here. So like I said, one way would be just basically take a direct file and serve it back as content.file, or I can just start programmatically constructing HTML. And this is what I want to talk about just a little bit. So primarily we want to do that in order to plug some extra content, some additional functionality into the source HTML. So we want to have placeholders in the source, and we may potentially want to define inner templates that we want to then use in computing the content that will be placed into the placeholders. So this is where the templating system will come into the play. And so here I basically just give the general advice that typically when you deal with content.page, in order to return HTML responses, you should probably consider just going from even from fresh, just start with templating and externalize your HTML into external resources and read them back using templating, instead of constructing the HTML responses on the server from F# code. But I actually show you both. So just in general, as a small summary here, so WebSharper.Sitelets basically have this representation where they take an endpoint type and they try to basically use that type to encode the different requests, and basically in representing the type system, the different endpoints or entry points to your application. And application can be basically an application that serves HTML, like a web application, or it can be a service, a microservice that basically respond to non-traditional requests, for example, posts or other HTTP verbs that you may send along with your request. So, and then basically sitelets are parameterized over this endpoint type. So you have your site, which will be a value of a sitelet over some endpoint. And the funny thing is, we can then start composing sitelets. So one of our developers could define a login related functionality, like a login, a logout, maybe a forgotten password kind of flow, and encapsulate the whole thing as a sitelet over those handful of endpoints. And I would probably say that those endpoints at that point would be represented as a discriminated union. And I can then receive this sitelet, and I can decide that within my larger sitelet, I want to embed that sitelet. And there are different combinators over sitelets to actually combine and control how the URL space will look like for such embeddings. And you can also introduce, using these sitelet combinators, your own content on top of the smaller sitelets that you're embedding. So this allows basically to encapsulate either part or the entire web applications within the type system, and then have those being able to be compiled into libraries and shared across with other projects from which you may actually want to reuse some of either the partial or the full sitelet functionality. So at this point, I should probably stop and say, okay, so far sitelets basically dealt with anything that happens on the server side. But the interesting thing is full stack applications, where you have a desire to actually write the client-side code in F# as well. So within sitelets, a very typical pattern that you will see is basically you have side by side the client-side and the server-side code, of course, both written in F#. And then there's this bridge which happens within your server-side markup into where you or through which you embed client-side functionality. So there are a couple helpers, so you will very typically spot these easily. in the code. One is called client, the other one is called hybrid. And I'll talk about these, but I think they kind of make sense just from the name. So yeah, so one more thing, sitelets, basically the endpoints where you want to address from within your own sitelet, part of the same sitelet or a different sitelet. You can compute the actual URL as a typed representation. So you will probably be not using the ordinary string concatenation to compute links. You will basically just ask your operating context, can you give me the link to this particular endpoint value? And here we have an echo, which is probably representing a page in the application, given two arguments, hello world and 42. And then we compute the link to it, and then we can use that. As you guess, we can take that and convert it to a string and then encode it in the markup that we return from another page. So this would be typical if you have like a template, and a template has a menu on the top of the page containing links to every one of the pages that you want linked from the menu. So this will be the way to actually get the links to point to those other pages or resources within the web application. And the nice thing is that if you then give this whole representation as a sitelet to somebody else and they decide to embed it in their own larger sitelet, well, all the URL spaces as they shift, context.link will be then, of course, it will return you the right URL, even in that embedding. So it will always be correct, as opposed to if you use string concatenation, you would have a lot of stale or incorrect or bad links. Okay, so this we have seen. So this was basically a small service taking ints and returning their square. Here's an SPA where we use the application.singlepage function, and then we simply just return a content.page, which is a fully formed HTML page with a single H1 body content inside of it. Here, if we stopped and then if we ran this as an application and examine the source, we would find that the head section of this page will have some additional WebSharper injected content. And that's for basically being able to light up server-side types that end on the client side, have their prototypes wired up so that they can be called as JavaScript values as well. So if you do the debugger in Chrome, you can interact with those values just like if they were sitting on the server, for example. But they also contain code to actually light up your own content. So if I used a chart, for example, in my application and embedded it using the client helper that we just saw, it will bring with it all the dependencies that it needs to actually execute. So we don't have to manually include any kind of resources. They are auto-managed and basically traversed as we output this page from the sitelet itself. It will be, or all those references will be produced on the fly automatically. So basically you get automatic resource management. And then finally, if you use the sitelet.infer function, you basically can give a function that takes any endpoint type and over which you probably need to do pattern matching like we do here. And in this case, we have an endpoint type represented as a discriminated union. So if you haven't seen F# syntax, this may strike you a little bit. So here I'm using this endpoint. It's an attribute. So normally you don't have to provide any kind of customization on these endpoint shapes or discriminated union shapes. But in this case, I do want to have some customization because I want to override the actual URL on which we intend to serve those endpoints. So we have a basic homepage at the root of the application, and we have a weather endpoint, which also takes a city as a string as an argument. So here in the infer function, we can see that if we receive the city, then I can call my own custom weather in that particular city function, which is of course operating on a server and computes, for example, the weather information for the given city. And then we just return that back as JSON or a page or however else you want to return it. So this is basically the most general skeleton code that you need to basically do microservices or full full stack client server applications. As you can see, the code is minimal, and we like it that way. Of course, you can further customize different aspects of how requests are basically handled and how they are parsed. You can here see a couple additional endpoint modifiers, which are given as attributes on the endpoint shapes. So here in the first one, I can say I want to, it's not an ID on the query, it should be version, for example, I think. So basically, it allows you to give an HTML query argument. The second one basically says, treat name and age within the arguments of find person as coming from a HTML form element, so basically form data. And then the third one says, I want to get that order, which is, as you can see on the type, is of type order data. We want to receive that as JSON posted to this /create endpoint. So basically, almost every kind of configuration that I can possibly imagine on how and where and what do I need to post to a particular entry point of a sitelet, I can encode all of that information in the type system using these different endpoint modifiers. All right. Another thing I should mention here is that once you start dealing with sitelets, you always have the option of actually just statically generating a sitelet. So once you define your own sitelet, instead of hosting it and running it as a web project, you can just change its type to HTML and give 4 or 5 lines of extra boilerplate code to then trigger the generation of the whole sitelet as HTML and JavaScript files. So basically, this takes a sitelet offline, generates all of its static content, and then you can maybe use that static content, plug it into GitHub Pages or your favorite web host, and then you just basically took your website and outsourced the hosting of it. Now, needless to say, you can only do these to applications that don't need a server side, or if their server side only references external services that are available. So you don't have RPC calling back to your server side because you don't have a server side. So for example, this would be like an offline site that would be good for like a company's website. Like our own company's website is actually implemented in F# as an offline sitelet. Okay, now let's talk about client-side stuff. So we have WebSharper.UI. This is basically the primary way of constructing client-side content. It's by default reactive. I'll show you what that means. But basically, the fundamental abstraction is a pagelet, which basically stands for any kind of content and or code that sits on the client side. Now, as we have shown, this actually is written in F#, and you need to annotate that F# code to say that that should be outputting JavaScript for that content. And then, as you saw, we can basically weave in that client-side content into server-side generated markup, all on the server in F# code. So basically giving us full stack applications. So here's an example. Here you can see the JavaScript attribute on the entire client module. So if you have multiple functions or multiple other content within that module, everything is assumed to be on the client. So when the WebSharper compiler comes across this file, it will basically generate JavaScript for everything inside. So there's also a compiler option that says treat every source file as client side, and then you can take an existing existing F# project and just translate it to JavaScript. So that would be one mode of operation, but more often you have this kind of a setup where you have the client side and the server side code within the same project, sometimes even within the same file, segmented into either functions or modules. Like here we have a module for client side, and then you attribute it, you annotate it to be on the client using the JavaScript attribute. So let's just peek in here. So we opened the WebSharper.UI HTML, and now we can use combinators, HTML combinators like input and h1 div. So the reason why we have this ELT dot is because ordinarily when you construct HTML, you have the you have a way to actually construct an empty HTML, so basically nothing. So when we look at the actual representation in the type system, it's a type called doc. It stands for a HTML document, but it's a type that can encode emptiness. It's a type that can encode a concatenation of values, and then it's also a type that can encode a single DOM node with its inner embedded content. So we need to clearly say that sometimes we know exactly that we have a tag, an HTML tag, like an input tag or an H1 tag, because we may want to actually change the label or the value inside that particular tag. So for example, here in input, or we have this output, it's an H1 tag. If you see here in the async call, it says output.text equals data. So basically we now are setting the content, the text of the H1 directly from in this case, an asynchronous event handler, which is sitting on the button that has a label called send. So this is, I think if you look in other languages, they do this very similarly. So this is basically, I think, fairly ubiquitous, just using HTML combinators represented as functions, here with the ability to actually also bind event handlers for different events. And that's it. So here we saw Till talked a little bit about asynchronous programming in F# versus C#. So here's an F# async, what it's called. It's a computation expression. We use let bang to actually fire up the asynchronous aspect. So here we will contact the server. We will call this RPC called do something, specifying the value from this input text box that we defined on the top of the function. So basically, whatever we write into the input box, when I click the button, it will be sent to the server. And then we basically, instead of a busy wait, the let bang causes this to be on a different thread and basically asynchronously executing. And once we come back from the server, then we take the resulting data, bind it to data, and then we go on and do something with it, like setting the output H1 tags content. And then we just fire that asynchronous block using async.start. That means start this immediately. All right, so this is how normally you would do this with almost any web framework. What we do actually, what we recommend instead, you can still do this, but we actually recommend that you use templating from ground up. So even for the smallest small details that you can possibly imagine, you should already be externalizing them into template files, load them using templating, and then once you have a type-safe access to those templates, then you can start filling in placeholders, binding event handlers, all in F#. And this, of course, is type-safe. So if you make a mistake, you misspell the name of the placeholder, you will get a compiler error and red squigglies immediately. So this, what we saw here, is actually taken from a sample. But if we switch it to using templates, then as you can see, the code shrinks down because we don't necessarily have to do any kind of HTML construction on the server. Instead, we just basically use the templating engine to do that construction for us based on an input HTML file, in this case, main.html. So at this point, I think we should create this project and just work with it. So I already did that. I have, did I do it? No. Oh, I think I know what happened. So here's my app 01, and if you open it, we get this. As you can see, instead of the startup and site that we had in the minimal project that we just saw, we now have a client FS and a remoting FS. Remember, this is coming from the template. Feel free to change it. Some people actually copy and paste everything into a single file. That's okay. So here, basically, the RPC is contained as a single function in the remoting FS file. It basically just provides an RPC function. As you can see, it has this attribute that tells the compiler that every time, typically a client-side code calls do something, then you should generate the client-server communication protocol, in this case, an RPC call, So wrapping the values, the input values into an envelope, sending it to the server. The server does some checking on the value, converts those values back into .NET representation, executes this function, and then returns the value, and the client receives that value as JSON, as a JSON payload. It extracts the values, activates them, setting up the interfaces, members, etc., that exist as .NET values on that package, and then basically it returns control to the calling client-side function. So this is what happens in RPC communication, but here the function itself, it's kind of silly. I don't understand why .NET doesn't have any better way of constructing a reverse string from a copy. So here we pass a string, we convert it to a char array, we reverse it as an array, and then we construct a string using that array. It's kind of silly if you ask me, but this is how it's done. And then what we do here is a computation expression. We asynchronously return calling input, which is our argument to this function, with this local function R. Okay, so that's remoting. And then another function or another file we have new within this client server project is client.fs. So this contains our JavaScript content, if you wish. So basically, we define the templates module, and inside we have our main template. This is a type provider. So if you're new to F#, this actually generates on the fly a type space based on the arguments to the type provider. I'll talk about these in a sec. So basically, pretty much, I mean, this requires IDE integration. So here we are in Visual Studio. It also works in Visual Studio Code. If you write this in Notepad, of course, it's not going to work. But if you come here, and if I complete the end of this line, in the background, the IDE will have generated the output of this type provider with these arguments, and it will basically shove all of the output into a type called main template. So as you can see, once we start using it, so for example, here we have a reference to main template. If I see what's inside, then I can see that main form is inside, and then I have some basic other generated content like vars and instance, but let's ignore that. So once I have main form, then I can see there are members for the different placeholders, members for the event handlers, and so on. So what I need to do is basically instantiate a main form, and then basically start plugging in the holes, binding the events or event handlers within the template. Now, needless to say, we should probably just take a peek on or in this main.html file. If you open it, now this is, for example, what our designer would have given us. So somebody sat down, designed an HTML page. It has style sheets and whatnot, and then they gave it back to us. And then we start plugging in our WebSharper content. So here's our body placeholder. Here's the template for the main form that I was talking about. So as you can see, it has basically the same structure that we saw implemented as F# code just a minute ago. It has an input box, it has a button next to it, and then it has a horizontal rule and an H4 tag for the server response. In this case, it actually puts it into a Bootstrap, an older CSS framework, but it uses a Jumbotron div to contain the end result. I think I have this running. Yeah, here we go. So basically, it's a two-page application. I'll show you how the two pages came about. But here we are on the home page, which embeds this client-side functionality. So this stuff here that I highlight has actually been generated as a JavaScript call. So we call a JavaScript part of the page initialization, and it basically lights up this part of the page. But if I actually saw what content did the server render for me when I requested this page, this would not be in here. There would only be a single placeholder into which this initialization code then renders this content. So if I do refresh page a lot, well, I can't. But if you did this like 1,000,000 times a second, you would see some kind of a flickering that this content is indeed being dynamically added to the page. So as you can see, well, let's type something so we can see that it's working. If I click send, it sends it to the server reverses it, sends it back to the client, and the client puts it into this Jumbotron as content. So this is what happened, but the way we implemented this, instead of encoding HTML in F#, we actually just used the template. Actually, this is the template. We instantiated the template on the server. We actually, on the client side code, and then we bound the on-click event. Note here that it's on-send. So if you go here, it will be called on-send. Now, let me show you something cool. Hopefully, I didn't get all these different instances of Visual Studio running mixed up. So let's say I changed this. So now I just renamed the on-click event handler. And if I retrigger, I don't even have to retrigger it. It took some time, but I could always retrigger by setting something here, changing some type provider invocation, which would then automatically regenerate all the types. But it does so periodically as well. So here I can see that onSend as an event handler doesn't exist anymore. So I can do code completion, and well, code completion in F# sometimes is a bit flaky, but you can see that now onSend2 type checks and everything is working. So I get immediate feedback just by changing the designer template. I can introduce further placeholders. I can do all kinds of things. And then I see the result, and I can code against those results immediately. Or if I change something that should break the code, it will break the code. But anyhow, so here I just renamed the event handler. It does the communication, etc. And in case you're wondering, I coded up the very same function, and that I showed on the slide. So I construct here the same content, but using HTML combinators instead of templates. And as you can see, it's slightly more verbose. And if I want to expose that, then I need to go here and I need to say, well, also embed in the homepage this function as a client side component or client side pagelet or functionality. So now if you rebuild and go back to this page, you can see here this icon is moving on the top. It says it's brewing something. So this is the compilation taking place, restarting the web server. And I think at this point, if I refresh the page, now I should see two of these forms indeed. So this is the one with the template. And this one is the inline HTML combinators in F#. So once again, I wouldn't recommend doing the inline HTML simply because if I want to change something within this presentation layer, I need to then recompile the project. As you saw, it only takes a couple seconds, but look at this. I can actually go in here and I can say, well, the button should actually be red. So I do this, I go here and I just refresh the page and boom, there's my red button. I didn't have to recompile anything, which can actually be a quite significant saving on compilation time if you have a larger project. Here, I switched over to the other window. It took half a second, so that would have been enough time to recompile anyhow. But I think it's just good practice that you don't maximize the CPU power, and you try to save on wherever you can. So basically here, we don't do any compilation. We simply just change the template and then reload the page. And the reason why that works is because this template is used in a particular way. Let me switch back to the slides, I think. So here you can see that I have some additional arguments to the type provider that provides the type safe access to this template. And one of the things I set on it is basically that the client-side loading behavior should be that it's loaded from the document, which means that if I changed it within the document, then it will automatically use what's in the document. Of course, how did it know? How did the server change get onto the client? Well, that's because I also have a server load when changed. So this, as soon as I changed it on the server, it tries to then propagate those changes the next time somebody requests the same page, which of course, as you saw, I had to do a refresh of the page, and then I got the red button. So this makes the developer workflow to actually make UI changes radically shorter than anything else. So basically what we found is that you can almost code your entire application logic in F# and then give that skeleton application to a designer and say, okay, now only touch the designer template and make this a nice looking application. And tomorrow the guy comes back and then says, here's my updated main.html. Now let's wire the whole thing up and see it's working. And all we have to do is just refresh the page. And then suddenly it becomes, from a skeleton application, a nice looking internet bank application, or whatever the application that we are coding is. All right, so I think at this point, we talked about sitelets. We saw how you can embed client-side functionality and client-side content using inline HTML and using templating from the server, and basically how you can implement full-stack applications. Now, there's one more bit that you may wonder about. What actually happens if you have some content that is being received from the server, but it takes time to initialize it? I mean, it's very typical that you go to a web shop, and then you see the web shop appear immediately, and then the things that you can buy in the web shop kind of load on the fly. So how do you do this? And also, how do you make it search engine optimization friendly? Obviously, when you index your whole website, you don't want just empty pages. You want to have some of the things that you can buy on your web shop in the CEO indexes. So the answer to that is basically it lies in how you inject something. So when you use the client function, you, as I said, get some HTML that doesn't have this content, but it has a placeholder and it has a dynamic JavaScript generated for you, which then, upon page initialization, injects into that placeholder the actual content that is represented in this by this function. So you can actually, instead of, because then if a search engine indexes your website, it will only see the initial page, not the one that had been decorated by the time the page has loaded, unless of course you make some attribution on the page itself to mark it so that the search engines can be operating in that way. But another way to do that would be to just basically use the hydrate function, which says, hey, take this function here, execute it, and then if it renders something on the server, inject it already when you serve the content. And then as soon as you served it in page initialization, run that code anyhow and just override whatever is in that particular rendering of the page. So typically what you can do here is you can, well, let me change. It doesn't matter which one I change. So let's say we change that one here. So I can go back here and I can say, oh, by the way, this is only if we are executing on the client, then this should be your content. But if we actually are not, which means that we are in the server, then we put something here, which is then rendered on hello from static rendering. So this will be in the response even initially. You could still put the same content as we saw here in here if you wanted, but because you don't have access to the event handlers and things like that on the server, it doesn't really make much sense. So for example, if you recall that on Facebook, if you go to your post, or if you go to somebody's feed, you see this kind of general looking, almost like the page without the content or with the content blurred out. So that's actually some static CSS and HTML. And then it almost instantly gets replaced with the actual content. So that blurred out part would be rendered here. And then this would be then the dynamic content then, which initializes itself as soon as you hit the server or hit the client and the page has loaded. Now, naturally, here we're not actually doing any kind of data loading from the server, but if we did, you would put the same kind of a RPC call to receive the data from the server, and then you would, instead of just setting it something like here, you would basically render a list of items based on the things that you received back from that RPC call to then populate the screen and make it look like a web shop. All right, so this was templating. Once again, here we see the client helper. You can use the hydrate helper as well if you want the behavior that I just described. And this is probably as simple as it gets to do full stack applications. Everything can be in the same file, just properly attributed that the client-side code should always get the JavaScript, RPCs should always get the RPC attribute, and then you can basically just run the sitelet by weaving these parts together. So now we could look at some UI examples. Luckily, I have these open. So here's an example. Ignore this because it's just presentation layer. So basically, here's the key part. On the UI, this particular input box, whatever value is written inside of it, we bind into a reactive variable. And then what we do is basically we take the view of those reactive variables or that reactive variable, and we do certain manipulations or transformations. For example, the first view will receive the initial view of whatever is written, and it will convert it to uppercase. This one will reverse it using the means that we saw earlier. This one will take whatever is written, split it at word boundaries, and figure out how many words do we have. And then this will just basically map that to a string. This will then look at the word count, and if it's even, then it will say even and odd. And this basically just takes a completely heterogeneous input, actually the input coordinates of our mouse, and then we'll show it on the screen. And then we weave all these views into actual markup using tables, HTML tables. We construct a table at the end. This is all presentation level stuff. It should really be in a template. But for the sake of this presentation, you can just kind of ignore the detail and live with the fact that these are using inline HTML combinators. And then you just basically put everything together. Here's my input field, and here's a table that then contains all the stuff we computed. So as you can see, as you type, it basically does these manipulations or transformations reactively. And in the code, there's nothing about changing any of this content. So basically, this is live. As soon as I change this, there are parts of the screen bound to the input value, and those are recomputed and updated on the UI. So if you recall, for example, in React, when you do reactive programming, basically you take a current state, and then here's the next state, and we compute the diff visually between the two, and then we apply the change sets that has happened from the current state to the next one, and then we apply those using the DOM diffing technique. So here we don't do DOM diffing, we actually do something much more clever. Here we track the data flow, and we can identify exactly what pieces on the screen need to be changed if, for example, this piece is changed. Now, this is so much more performant that I could have 1,000 by 1,000 matrix, like a spreadsheet where each of the cells is interdependent with everything. Perfectly just fine, but 1,000 UI. Hope you guys can still see me. I see that we're not hello. So this last bit here, you can see as I move the mouse, I can basically check my mouse positions instantly. So here, this allows to develop applications that actually look at what you're doing on the application itself. You could take this info and stream it back to the server, save it in a database, and you could do like user UI studies on how the users perceive your page. So this was an example. There are many, many more examples. I'm not going to go into them because I think I'm out of time. But basically, it's the concept is the typical two-way bound controls that we see elsewhere. So you can bind a reactive variable to an input text box, and that same variable can be set programmatically and updating vice versa. And then we have a stream of values that basically represent the past. And one nice, interesting technique that you can also use with this is you can go back. There's something called time travel debugging, where you can take an application written with this kind of reactive model, and then you can say, can you please go back in time where the state was this and this? and you can kind of scroll back. I'll give some pointers in a sec where you can check how to do that. So we talked about templating. So basically this gives strongly typed access to the placeholders and event handlers within your templates that you define, externalized nicely in designer source files. And all the dependencies will be auto-computed depending on what you plug in to those placeholders. And we saw that this is basically how you trigger the templating type provider. And then once you have a reference to your inner templates, you can start instantiating them, setting the different placeholders and event handlers, and then converting everything to a doc, which basically seals everything. And at that point, you can inject that content or return it from a sitelet or do whatever you wish. So templating, I think I covered that plenty. Another bit that I just want to spend a minute to talk about is MVU. Probably you all have heard about. The functional web programming community does MVU most of the time. So this is the model view update. So with WebSharper, you can also do MVU. There's a package called WebSharper.MVU, which you can plug into your project and then use the MVU style. The only difference here is that the render function, which is our view function, doesn't just take the model, but it takes the view of the model. Because remember here, the whole idea is that the model itself is a reactive value. So here we are interested in the current view of the model, the current state of the model, I should say, and then we render it into a doc. And then the update function basically receives the same message, receives the same model, and computes the same model entity that the regular MVU does. So basically, here are a couple demos that I just show in a sec, but you can check the source code and you can check for examples either on Try WebSharper or in that GitHub repo. And just remember that the render function has this slight deviance or difference to the traditional MVU approach that you may know from the Elm architecture, or if you use F#, you may have heard about something called Elmish. One more bit, WebSharper.Forms. This is for reactive declarative forms represented as F# values in the type system. If you have seen formlets before, which is a nice functional programming abstraction, this looks a lot like formlets, except it's reactive. So you can compose things using reactive variables, and you can set those reactive variables to initialize your forms, and you can also read anytime in between. For example, in the form.run, I can read whatever is written into my form just by reading the two-way bound reactive variables representing the placeholders or representing the inputs within that form that I have constructed. So this is basically, as you can see, there's absolutely no presentation layer definition here. Form.return basically just assembles a form value. Forms with submit basically attaches a submit functionality to it so it can be submitted, which typically you can render it as a submit button, or you can render it as just clicking on something and then moving on to the next bit. And then we have a form.run function, which basically takes here the tuple, the u, comma p, as you can see here on form.return. That is the two constituents that we receive from the user. One is the username and the other one is the password, and we pass that along as a tuple, and then form.run takes that tuple and does something with it. It basically just, in this case, gives a JavaScript alert. So this doesn't have anything about the presentation layer. You need to have a form.render function, so you pipe this form into the form render function, and here you can give a concrete presentation layer. Here again, I used HTML, inline HTML, but you should probably just use templates to be the most productive. All right, I don't have time to talk about WebSharper interfaces, but these would be ways to bring in existing JavaScript code bases and talk to those code bases from F#. Now, needless to say, when we have a JavaScript annotated F# functionality, a whole module, a whole project, or a single file, or just one single function, when we compile it with WebSharper, there will be JavaScript code for it, which you can, of course, interact with using typical JavaScript means, the Chrome debugger, etc. But here, the specialty about these bindings is that they are represented in the type system. and at the end they produce you DLLs and libraries that you can package up as NuGet packages and share across with other people or your other consuming projects. So just a couple pointers. The main organization on GitHub is .NET WebSharper. There are samples, dozens and dozens of different samples, many 80, 90 different extensions to different JavaScript libraries. WebSharper charting, I highlighted here and put the repo itself, because the last bit I want to show you is that I copy paste, and I'll show you from where. So here's the .NET or the GitHub page for charting for WebSharper. It has various examples and a full documentation. I just copy pasted these 3 lines. I pasted it here, and if you go slightly below, there's an example here that says how you can actually configure a renderer. So I also copied that line, and now in my server-side code on my homepage, I just embed that chart as well, and recompile, go back to our homepage. This has started to brew something, so it's compiling. Actually, the compilation has long taken place already. This is just about restarting the server. But if you go down now, we have this chart, and then we can of course change the code to make a dynamic real-time chart, whatever you want. It's all in here. So it's a very flexible thing. But if you do a lot of charting, you'll probably be aware that F# has its own charting library called F#.Charting. So here, WebSharper charting actually keeps most of the same API. So you can almost have your F# charting code and just put very easily the same code on the web with WebSharper charting. And it has a lot of capabilities, from real-life charts, even connected to WebSockets, communicating back and forth to the server, and other lots of different chart types. And the interesting thing about the WebSharper charting library itself is that you can configure different renderers, which then take this high-level API and map it to the underlying JavaScript technology. By default, we use chart.js, which I think you can see here, that we use the chart.js renderer, and then we just basically take this chart and give the render function of the chart.js renderer, and then configure it with some size, and boom, that's it. So I think that is all. I apologize for going over a few minutes. I always do. But at this point, I think I'm ready for any questions you may have for me. And thank you very much for listening.
Thank you very much, Adam. Very nice
Thank you, guys.
presentation. Thank you. Yeah, no questions so far in the chat. I have some questions for you. How come you went into F# and functional languages?
That's interesting. So like I said, I was doing research in functional programming. We were working on functional programming compilers. And then we had this compiler called Mojave compiler, where we had different front ends, different back ends. And the cool thing about the compiler itself was that the intermediate language of all these front ends was a functional intermediate language. So kind of like in .NET, you have the CIL, the common intermediate language. It's not a functional intermediate language. It allows to do imperative stuff, object-oriented stuff, etc. In our compiler, the intermediate language was a functional, so basically mutable by automatically by default, etc. And having basically some extra guarantees stemming from the fact that it was a functional representation. And basically we broke down every front-end language to that representation, which then allowed us to reason about these programs in a very different level, because now we knew that the actual representation that we are reasoning about is a functional representation with guarantees. So we had an integrated theorem prover on this compiler architecture, and it was a lot of fun. So I worked mostly on the front-end side of that, and I also did some work on the reasoning level. And so this was almost 20 years ago, so a long time ago. And we did all the work in OCaml. And basically, yeah, so we had an awesome awesome code base, just tremendous amount of stuff that I learned about functional programming just from that one project alone. So I basically got very much interested and deeply vested in OCaml at that point. And for 3 years, I basically worked on this and many other projects within the research group. And when I finished, I came home to Hungary, and then I formed my company, IntelliFactory, that you guys saw on the first slide. And ever since, we basically dealt with the same kind of ideas, did a lot of research and development. We had a lot of interns, a lot of people coming to us and joining from, I think we had people from 18 different countries already. And most of the years we actually managed to publish in academic conferences. So we have research papers on declarative UIs, WebSharper itself, a lot of interesting things that I think are very innovative in a way. Nowadays, we do a mixture of functional programming and code synthesis and artificial intelligence. So I think those are kind of cool as well. I would love to find, like-minded people. So if anybody's into those, please reach out to me. But coming from this deep background in OCaml, when I first saw F# in 2002, it was just this tiny project that one or two people used besides Don Syme. And I got immediately interested because I saw the potential of a language that looks like OCaml, but also running on a much more commercially supported framework, the .NET framework at that time. So I basically fell immediately in love with F#, and from that time, the progression and the progress that has been made to F#, I think, is amazing. The community is huge now. There are lots of people working in web. So actually what you saw here, WebSharper, I think is one of the oldest web technologies, but it has a slightly different scope and direction than the other ones available. I think what I can maybe summarize the direction of WebSharper as is that we don't really want you to be a JavaScript developer and have a JavaScript mindset when you develop applications. With WebSharper, you should have a functional mindset. You should have an F# mindset, and you should not worry about what things look like in JavaScript and how things are interacting with JavaScript and how the client and the server side can interact with each other. All of those are details that you should not be concerned about. You should just write your business logic and have a designer to give you nice HTML templates, and you have your applications. So this is our mindset. And then a few years ago, as you are probably all aware, there has been a lot of buzz created with or about or around WebAssembly. And we got interested in WebAssembly, and we started developing some technologies, some developer tools around WebAssembly development. And now the main interest that we have is basically keeping the same kind of applications that you saw here, but also producing WebAssembly-based applications, not just applications that run on JavaScript. So from nearly the same code base, jumping from JavaScript into WebAssembly. And this has some interesting aspects. At some point, we even entertained writing our own compiler. Well, WebSharper has its own compiler, but we also were entertaining writing a specialized language and the compiler to write all this in that looked very much like F#. But I mean, F# has so much more momentum and has just so much more features that it wouldn't make any sense to do that. So instead, we worked with F# and worked with the type provider angle of F# to actually facilitate some of the same tools and automation that we planned originally to go between F#, JavaScript, and WebAssembly. So that's pretty much where we are. But like I said, nowadays, for the past couple of years, we had mostly been working with WebAssembly, targeting WebAssembly, some language-related tools around that. But most of the time nowadays, we work on the artificial intelligence and WebSharper and WebAssembly part and code synthesis.
Cool. Thank you very much. I have one more question, Adam. I mean, you came from OCaml, and you.
Yes.
How come you went into like web and putting it out on HTML and making web pages?
That's a good question.
It is.
So, yeah, because from my background, you wouldn't suspect that I would want to do anything with web at all, because I had all this experience using server sides or just normal thick clients or backend like service type work and compilers and so on. But I very soon learned that everything around then was starting to move into thin clients. So everything, instead of installing an application, people just said, hey, go to this URL, sign up for it, and then use it. So applications started to become available on the web. So like you had Office, you had Word, you had Excel, but very soon you had the same thing, the same capabilities online as a web application. And if you continue that progression, nowadays what we see is that basically you want to have universal applications that are also web-based with or without universal abstractions for UI and applications. So, so they can be run on different operating systems or even outside of a browser, even if they are web applications, etc. So WebAssembly is one big enabler in this whole futuristic outlook. And I strongly believe in it. But going back to your question, I basically had this realization that if I want to share anything with, for example, a customer, or if I want to do anything at all that is, you know, for people to use, the easiest platform was the web. You just basically had almost no other easy means to share something with a mass of people, and so easily as the web. Of course, I could have made Linux applications and, you know, make people install those applications on their machines, but it made much more sense to share these as web applications. And at that point in 2003, 2004, I was basically very much interested in F Sharp. I switched to F Sharp completely by then. So from OCaml, I went to F Sharp roughly around 2003. And my first big sort of a project for myself was establishing the bridge to use F Sharp and output web applications. So of course, back then there was ASP.NET. You had these code behind files and markup files, ASPX files, if you remember.
Yes.
And I actually, one of the first things in the community in F Sharp, there had already been a couple people. Thomas Petracek, for example, he wrote a code DOM provider so that the code behind mechanism would work for F Sharp. I basically had similar work enabling F Sharp to actually output and integrate with ASP.NET. And from there, I basically immediately started lacking the ability to write something in F Sharp and execute it in JavaScript. And this is where WebSharper as an idea was born. 2005, 2006, we had the first initial releases. And then from there, you know, once we released, lots of people were interested in it. We got a lot of requests. We started working with the community, and we basically, you know, spent more than 10, 12, 14 years now getting to where we are. So, you know, it's been a long journey, but, you know, from very early on, I was basically, I wouldn't say I was forced to write web applications. Let's just say that I was inclined, or I was inspired to work with web and uncover, you know, what kind of technologies would enable me to do that in F Sharp. And so that's my little story. I spent a long time. I worked on a lot of dozens of enterprise grade F Sharp applications, and it's pure joy. I mean, it's just so much different than writing applications in PHP or Java, or, you know, client-side stuff, JavaScript, or anything else. It doesn't even compare. The productivity is just absolutely over the bar in any respect. The debugging tools that we have based on the functional, for example, the MVU pattern and source maps. We of course generate source maps from WebSharper. I didn't show you that. So basically all of these applications that we saw in the browser, I could have debugged them using F Sharp in Chrome. So it just makes it very easy. And I really enjoy working on these applications. we're always full of work, lots of interesting ideas that we are exploring. We try to combine research and development so that it benefits everyone in the company, and I think we have a good situation around that.
Sounds interesting. Thank you again, Adam. Thanks for coming.
Thank you very much for having me.
Yeah, very interesting. I also started my career actually as working with front end or pure HTML and then going to the server side.
Nice.
Yes. Thank you very much.
And you used what language?
No, in the beginning we used pure HTML, and then this was in the mid-90s. I used Cold Fusion, if you remember.
Cold Fusion.
Yes,
Yeah,
I don't know if it's still around or if it's kind of dead at this point.
I think it may be. Yeah, it may be.
Okay.
Still around. These things never disappear.
No, because someone built the page and it has to be maintained forever and ever, and then there are some poor people hacking away in that. Maybe. Yeah. With that.
All right. Thank you very much again.
Yeah, thank you very much, Adam. With that, thank you very much for joining tonight and staying with us, and all your shout outs and all the business in the chat. And again, please join us on the 25th. We will be live from Funnel. So if you're in Stockholm, please join in Funnel. And then we're back on the 8th of November, and then again on 6th of December. With that, thank you everyone, and have a pleasant evening. Bye.